Water, a certain substance that can be seen around the world.
Something that is essential in every living organism.
A substance composed of the chemical element hydrogen and oxygen that is existing in gaseous, liquid, and solid states.
Most of all, it popularly represents life.
About 71% of our planet's surface is covered with water. 336 billion gallons of water, and that's over 48 billions of water for every person on Earth. It is one of the most plentiful and essential compounds, a tasteless and odorless liquid at a room temperature. It has the important ability to dissolve many other substances. In short, it is known to be universal solvent.
But one of the biggest problems today is water. In fact, about 1 out of 5 people in the world does not have access to clean water. The said 71% of the Earth's surface that is composed of water, only 2.5% of it is usable. Some of the projections shows that by 2050, more than half of the population will be living in water-stressed areas. That is over 4 billion people. These aren't just issues in some developing countries, something you hear about elsewhere. These are things that are usually happening in our community all the time.
And due to those occurring problems, there are places where water is a huge problem. There is no near source of clean water, and due to that, they rely on water that is mainly dirty or worse, water that is contaminated. That's one of the results of poor and unclean water. Good thing that our country, which is the Philippines, projected 1,019 bodies of water according to the Environmental Management Bureau in 2019. But with the rapid increase in population, urbanization, industrialization, reduced the quality of Philippine waters, especially in densely populated areas and regions of industrial and agricultural activities. The discharge of domestic and industrial wastewater and agricultural runoff has caused extensive pollution of the receiving water bodies.
Access to clean and adequate water remains an acute seasonal problem in urban and coastal areas in the Philippines. The National Capital Region, or the Metro Manila, the Central Luzon, Southern Tagalog, and Central Visayas are the 4 urban critical regions in terms of water supply, quantity, and quality. Here in Region 4A, which involves Cavite, Laguna, Batangas, Quezon, and Rizal, the main source of water supply for drinking and or cooking were their own community water systems. Despite the fact that there are water stations that provide clean and safe water, poverty remains a huge factor as a reason for people to get their drinking water directly from the faucets, which aren't safe.
In a forum conducted by the government of Batangas and USA, it was stated that the whole province is suffering from unsafe and unclean water due to overpopulation, urbanization, and environmental degradation. It was also stated that different areas, especially rural, are suffering from water shortage because of lack of working water system and technology that can support it. People from rural areas are enduring a limited amount of water in a limited amount of time.
One of the aforementioned areas in the forum is the municipality of San Luis, Batangas. Here, we conducted a survey to 20 respondents, and as a result, water is the major community problem in San Luis. This area is considered as a 4th-class municipality which provides settlement for almost 34,000 residents. This area can be found near Taal, Lemery, and Bawan. In description, this place can be considered as a partially urban, partially rural, and partially coastal because it has a sea residing in it.
However, that didn't change the fact that this place still suffers from water shortage. The salt water coming from the sea isn't potable enough for people to rely on it for their everyday lives. It is also starting to become polluted because some of the sewage system in the area go directly to this body of water.
With that being said, we conducted a brainstorming within ourselves, thinking of something that can aid the shortage of water supply. We think of something efficient, reliable, economy-friendly, and something innovative. After a long time of brainstorming, we came up on a conclusion. Why not use the remaining 68.5% of water around us? Why should we waste something that nature had given us? After the critical evaluation and gathering suggestions and feedbacks, our group came up with the concept. a solution that can be used in solving the said problem, which is named S.W.A.M.P.
S.W.A.M.P, acronym for Saltwater Advanced Mechanical Purifier. The Saltwater Advanced Mechanical Purifier, also known as S.W.A.M.P, aims to provide clean, portable, and renewable water to communities suffering from water shortage. With the help of related researches and literatures, different processes and terminologies were used to build the system. Some of them are flocculation, coagulations, clarifiers, and raw membrane.
For the mechanism, here are the questions to be answered. How will the device or technology work or function? How will it operate? And what will be the inputs and the outputs? The S.W.A.M.P is a system which will be located above Balayan Bay, as it will serve as a source of water of the machine for the community whenever needed. It can also help to lessen the burden of high cost of water.
According to an article entitled What is Solar Energy, which was written in March 2021, solar energy is a type of energy which uses the sun's light and heat to generate renewable or green power, meaning not only is it limited but is also safe to use compared to coals, which produce carbon footprints which may lead to the depletion of the ozone layer. That is one reason why S.W.A.M.P draws power from this type of energy. Another thing is based on the geographical aspect, because Philippines is placed almost in the equatorial belt and it experiences a tropical season, which would be an advantage for someone using solar energy. Unlike other countries with 4 seasons, the Philippines only has 2 seasons, which is also assurance for longer sunny days ahead.
The machine can also function even though there is a lack of sunlight around it. S.W.A.M.P can also be powered by another source of sustainable and natural source of energy, which is tidal energy. According to the study provided by ArenaWire on 2017, tidal energy works via a turbine works like a wind turbine, with blades rotating 12 to 18 times a minute, depending on the tide strength. Our machine only uses turbines, but there is 2 methods of gathering energy with this technology, and those are turbines and paddles. The turbine is connected to a gearbox that turns the generator, creating electricity. In simple terms, it can be powered by a natural rise and fall of the ocean and tide currents. The stronger the ocean current is, the more energy provided by the machine.
Let's discuss how this whole thing works. This type of clarifier can be seen in sewage treatment, water treatment plants, mining facilities, and anywhere that has a large amount of water which needs to be treated prior to being discharged to the environment or the community.
The process will start when the pumping system inside the clarifier begins to pump salt water from the deep bay. At the bottom, we can see the influent, which serves as the inlet where the liquid will enter the clarifier. Inside, there will be different channels and ports. Also, the baffle plate known as energy dissipating inlet, which the salt water will flow. Its purpose is to slow down the velocity of the water. Through this, it's going to settle a lot faster. In short, slower velocity will lead to better and quicker sedimentation to separate suspended solids to the salt water. The efficiency and capacity will be increased.
After that, there will be another baffle plate. Once the velocity has been slowed down, the 3 zones in the clarifier will do the work. The inlet zone, settling zone, and finally, the outlet zone. The settling zone is where the solids will gradually separate from the salt water due to the force of gravity. The solids that are heavier than liquids will settle down at the bottom of the clarifier, which will be collected by rake arms and scraper blades, directing it in sludge field.
However, the floatable solids will accumulate on the surface as scum. There will be what we call a skimmer, specially built for the floatable solids. It will push the scum outwards to the outside periphery of the clarifier and it will be discharged into as scum free. In order to prevent scums from going to the clean water outlet or the effluent, there will be a scum baffle to stop it. The clean water will pass through a channel or the effluent launder until it flows out to the pipe designated for further treatment.
The salt water that will come from the clarifier will then be pumped out through the pumping station beside it. The water will be directed to the filtration system. After undergoing the process of clarification, the water will then be pumped into the filtration system. Various filtering materials remove substances such as small amounts of suspended matter. As you can see, there are 5 filtering tanks present, 3 of which contain multimedia filters, while the other 2 contain the only carbon for better filtration.
The first layer in the filter is the mechanical filter media. Sand and crushed rocks will be used as they are the best type of filtration sand since those have less chance of being contaminated with pathogens or organic material and are efficient. They are relatively compact and cost competitive for removing dissolved waste from recirculating aquaculture systems.
The second layer is a biological filter media which is made up of porous ceramic material that is known for its affordability, longevity, and powerful filtration properties. The tiny pores of the ceramic filter makes it extremely efficient at removing particulate matter and fine sediment. Also, it is a highly effective barrier to bacterial pathogens and waterborne cysts including E. coli, Cryptosporidium, Giardia, and Salmonella.
The last layer is a chemical filter media containing activated carbon, as each piece has been processed to create hundreds of little pores that cannot be seen with the naked eye. These tiny holes trap pollutants such as chlorine and chloramine, dissolved proteins, water discoloration, bad smells, and etc., separating them from the water column.
With this, several undissolved substances can be removed simultaneously. These filters can be efficiently cleaned and maintained using hot water. As we may know, a simple filtration system will not remove all the contaminants and small particles of the salt water, and that is why it will undergo flocculation and coagulation processes. These are fundamental for wastewater treatment and were already used by the ancient Egyptians in 1300s BC.
The salt water may have high turbidity due to the presence of many suspended particles. Adding flocculants will cause the small particles to group or clump together in order to create bigger flocks, then settle down. Turbidity of water is caused by 2 types of particles, organic and inorganic particles. The examples of organic particles are algae and bacteria, whereas inorganic particles are, for example, clay. Both particles have in common: they can float because of their small size. Suspended particles that are too light to settle down are called colloids.
Almost all colloids have negatively charged surfaces. The negatively charged surface will attract positively charged ions in the water so that the colloids form a first layer. The effect is very similar to magnets, like poles repel but opposite poles attract each other.
Over time, colloids form a second diffused layer with positively and negatively charged ions, called a double layer. The double layer creates a responsive force which prevents 2 colloids from sticking to each other. The colloids stay suspended in the water and move around to avoid collision with other colloids.
To overcome this behavior and to clump colloids together for particles, settling flocculants are typically used as alum and ferric alum, which are ideal as flocculants because they form high number of ions when they get in contact with water. These ions will bind together with the colloids and neutralize responsive forces, mixing the water, allowing the colloids to stick together to form bigger flocks and settle down to the tank bottom within wastewater treatment plants.
Seawater can be economically and reliably converted to potable water through a process known as seawater reverse osmosis. The process starts by extracting water from the ocean. It is a naturally occurring process where a solvent such as water passes through a semi-permeable barrier. This barrier or membranes allow some things to pass through it but not others. In nature, the direction of flow through the membrane is from a less concentrated solution, such as fresh water, to a more concentrated solution, such as seawater, until equilibrium is reached. Reverse osmosis is when the opposite occurs.
By pressurizing the concentrated solution, we are able to force water molecules to pass from the salty water solution through the membrane to fresh water to protect the reverse osmosis membrane from becoming clogged by solid particles that can be suspended into seawater. Reverse osmosis are typically made from yarn-like synthetic materials, that is, round into cartridges. These remove even smaller solid particles from the seawater.
High pressure pumps increase the pressure of the seawater up to 1,000 pounds per square inch. The pressure needs to be sufficiently high to overcome the naturally occurring pressure and force the water from the saltwater side through the reverse osmosis membranes to the fresh water side.
The saltwater particles in the seawater are ejected from passing through the membrane to the freshwater side and remain behind on the concentrated saltwater side. The reverse osmosis membrane can be thought of as a number of sealed envelopes connected on their own ends to a tube. There are spacers between each envelope which allow water to flow across the membranes, and the membranes, envelopes, and spacers are then wound around the tube. Reverse osmosis membranes are enclosed in a fiberglass shell and the membranes are connected end to end. Usually 6 to 7 membranes together and housed in vessels that are built to withstand pressures up to 1,200 psi.
As the water enters the pressure vessel and flows across the membrane surface, the water molecules are forced into and through the membrane, leaving the salt molecules behind. The salted water passes through the membrane and emerges at a low pressure where it is located in a tube and directed to one of the pressure vessels. The concentrated salt stream, which is rejected from flowing through the membrane, continues to pass across the membrane surface where it is collected separately. The stream is transferred to an equal volume of an incoming seawater in an isobaric energy recovery device. The energy recovery device significantly reduces the plant's operating cost by recovering the concentrated salt stream energy and using it to pressurize 60% of the seawater that is fed to the membranes.
The pressurized seawater leaving the energy recovery device has its pressure boosted by a small booster pump so that it is at the same pressure as the seawater leaving the high pressure pump. The boost is necessary as some pressures has been lost as the stream travels through the reverse osmosis system. Approximately 40% of the seawater that enters the system is converted to potable water during the reverse osmosis process. The water will then travel from the reverse osmosis to the pressure vessels and then it can now go through the community water distribution system located in San Luis, Batangas, going to the residential homes in the community and businesses.
When proper conservation of natural water resources is practiced, water reuse has been applied and the water deficit still remains. Seawater reverse osmosis can offer a sustainable alternative with good stewardship.
It can provide life-sustaining water for coastal communities and the salted water supplies, which are not susceptible to drought and other natural disasters, can provide a clean, safe, portable water supply.
Water shortage is still one of the biggest problems that we encounter in today's society, which is ironic considering 3/4 of the world's totality contains water. However, as time passes by, technology continues to rise, and the knowledge we acquire is very important in these types of situations. The team believed that the maximization of our natural resources will help a lot in solving the problems we encounter today. And in our case, we should convert seawater to potable and clean water for the society to use. That is why Project S.W.A.M.P was put into action, which follows a set of processes and are made up of advanced technology which would not only help the people who need it, but also help the world who needs it more.